Okay, so we are looking at dot product of algebraic vectors. That corresponds to 7.4 in your textbook. Previously, we looked at dot product of geometric vectors, and we said that if you have A dot B, this is equal to magnitude of A, magnitude of B times cos theta. Okay, that was for geometric vectors. So how do we do it with algebraic vectors if we have coordinates? So how do we do the dot product? This is how it goes. Let's say you have a vector A, coordinates xa, ya, za, and we have a vector B, coordinates xb, yb, zb. So when you do the dot product A dot B, so you multiply the x coordinates of those two vectors, xa and xb, and then plus you multiply y coordinates, ya and yb, plus you multiply the z coordinates. So as you see from here, you get a scalar, right? You don't get three coordinates, which represents a, a vector in 3D system, but you will only get a scalar. So we did this, it was the same thing with the geometric vectors, right? When you do the dot product of two vectors, you ended up with a scalar. Obviously, it is the same thing with algebraic vectors. So let's look at some examples. So we have vector A and vector B. For each case, find the dot product of the vectors A and B. So A dot B. So we multiply the x coordinates. Maybe I'll write it for the first one. So 1 times 0 plus, so we multiply y coordinates, so -2 times -1, -2 times -1, plus 0 times 2, 0 times 2. So you get 0 plus 2 plus 0. So that product of this is 2. Okay, so let's look at B. So we are given vector A and vector B in 3D. But this time they are given with I vector and J vector, which are the unit vectors, basis unit vectors. So what we're going to do, first we're going to convert them and write it with the coordinates. So negative I gives you -1, 2J gives you 2. We don't see the K. That means that K is, Z coordinate is 0. Okay, let's do the same thing with B. So we see I, that gives you 1, -2J, -2, -K gives you -1. So now we're going to do A dot B. So we multiply the x coordinates. -1 times 1 gives you -1, plus y coordinates multiply 2 times 2, 4, and z coordinates 0 times -1, 0. So we end up with, that is -4, sorry, plus -4. So you end up with -5. Okay, give me a second now. Let me check. Okay, so I answered. So Tayyab, so you're here. Let me fix the attendance and we continue. All right, now let's look at example 2. We have I dot I, okay. You can write, Well, you can use uh, geometric vectors method here or algebraic vectors method. So let's use algebraic first. So I vector, if you want to write with the coordinates, we learned that before, 1, 0, 0. And you are doing that product with, again, another I, right? 1, 0, 0. So what do you get? 1 times 1, 1. 0 times 0, 0. 0 times 0 is 0. Okay, is 0. So you end up with 1. So I dot 1, I dot I is 1. Okay, so if you wanted to use, let's say, a geometric method for this one, okay, so magnitude of I, so let me do it on a piece of paper. Magnitude of I is 1, as you know. So when you do I dot I using the geometric method, geometric vectors method, so magnitude of I times cos theta. So magnitude of I is 1, so another 1, and cos theta. So you have the same vector I, right? You have two of them, but then the angle between them, as you see, is 0. So cos 0 degree, and cos 0 is 1. So you end up with 1 times 1 times 1, which is 1. Okay. And then if you use algebraic vectors method, so you get also 1. So j dot j. So this time we do, so j, as you know, 0, 1, 0. Okay. And then if you want to write the second time, 0, 1, 0. So when you do j dot j, so 0 times 0, 0. 1 times 1, 1. 0 times 0 is 0. So you end up with 1 again. Okay. And if you do k dot k, it is the same idea. You will end up with 1. How about I dot j? Okay. Uh, I is, well, we can use these ones here. Okay. So I is here, j is there. So 1 times 0 is 0 plus 0 times 1 is 0 plus 0 times 0 is 0. So you get 0. And this should make sense. Again, if we look at it in terms of geometric vectors, where you're doing I dot j, magnitude of j times cos theta. And magnitude of I is 1, magnitude of j is 1. How about the angle between them? So we learned that the angle between all those axes, right, x, y, and z axis, so we have 90 degree, right? So cosine 90, and we know that cosine 90 is 0, so you end up with 0. Okay, so that will happen with, like, you know, I dot j, k dot I, or j dot k, you will get 0. Okay, so this is going to be 0 as well. But again, k is 0, 0, 1, dot I is 1, 0, 0. So you can see that you get 0. Okay, so let's look at the next item. Angle between two vectors. The angle theta between A and B, okay, when position tail to tail, is given by cos theta equals A dot B over magnitude of A times magnitude of B. And it should make sense. So because, see, we had this formula, right? And if you isolate cos theta from here, you divide both sides by magnitude of A and magnitude of B. So obviously you end up with this formula, cos theta equals A dot B over magnitude of A times magnitude of B. So let's say you're calculating the angle and you end up with cos theta equals 1. Okay. So this means that A and B are parallel and then have same direction. And they should make sense, because if you have cos theta equals 1, then theta is either 0 degree or 360. But again, when we are doing dot product, we always take an angle between 0 and 180. So then theta must be 0 degree. And if you have cos theta equals -1, that's going to give you theta equals 180 degree. And if you're getting cos theta equals 0, and we know that theta is 90 degree. So if cos theta is -1, A and B parallel, but they have opposite direction. When cos theta equals 0, A and B are perpendicular. Example 3. For each case, find the angle between the vectors A and B. Okay, so cos theta equals A dot B over magnitude of A, magnitude of B. So let's do those calculations. So A dot B, multiply the x coordinates, 1 times 0, 0. Y coordinates, -2 times -1 gives you +2. -1 times 2 is -2. So you get 0. So A dot B is 0. Well, it doesn't even matter what the magnitudes are. You could calculate the magnitudes, but since the numerator is 0, you will end up with 0 for sure. But the magnitude of this would be 4, 1, 1 to 6. And this one is 1, 4, 5. Okay, root 5. So you get root 6 times root 5. But again, since numerator is 0, you get cos theta equals 0. So then we know that now A and B are perpendicular because theta is 90 degree. Okay, let's look at part B. Cos theta equals A dot B over magnitude of A, magnitude of B. Let's convert those IJK and write them with the coordinates. Okay, so A, -1, 0, -2, and B, I is not there, 0, -2, and 1. Okay, so let's do A dot B, -1 times 0, 0, 0 times -2, 0, -2 times 1, -2. Okay, so this is equal to -2. So let's calculate the magnitude of A. Square of 1 is 1, square of 2 is 4, so root 5. So magnitude of B. So 2 square 4, 1 square 1, so root 5. But then we have -2 over root 5 times root 5 here. Root 5 times root 5 is 5. So you get -2 over 5 here for cos theta. Then if you do inverse, cos inverse -0.4, so 113.6 degree. All right. Okay, example 4. It says find a non-zero vector perpendicular to each of the vectors, A and B. Well, this is what we are going to use, right? So we don't know that non-zero vector that is perpendicular to both of them. Let's call that vector C. Okay, so since we don't know the coordinates, I'm just going to name the coordinates as X, Y, and Z, and we will try to find out what those coordinates are. Okay, so if A and C are perpendicular, then I expect that product of them being 0. Okay, so I want, then you want that product to be 0. Okay, so what is A dot C then? 1 times X is X, 5 times Y is 5Y, negative 1 times Z minus Z. So X plus 5Y. Okay, so their dot product is also 0. So B dot C is going to be also 0. Negative 3 times X, negative 3X. 1 times Y plus Y, 2 times Z plus 2Z. We have 3 unknowns, X, Y, Z, and 2 equations. Okay, so at the end, actually, we won't be able to solve what X, Y, and Z, but we can find the relation between those coordinates, okay, using these 2 equations. This is how we're going to do it. From the first equation, so you can isolate one of the variables. Let's say we isolate X from here. So negative 5Y plus Z equals X. Okay, so I'm going to take that and substitute this negative 5Y plus Z for X in the second equation. Negative 3, negative 5Y plus Z is the X, plus Y plus 2Z. So we get 15Y minus 3Z plus Y plus 2Z. What do we have here? 16Y minus Z. Okay, so if we isolate Z from here, we get 16Y. Okay, we don't know what X is, we don't know what Y is, we don't know what Z is, but we know that at the end, Z coordinate is going to be 16 times the Y coordinate. So it looks like we can write every coordinate in terms of with one coordinate. Let's say Z equals 16Y. So I can take this 16Y and sub in here for Z and see what X is equal to. Okay, so negative 5Y plus Z is 16Y equals X and 11Y equals X. So this is telling you that then, okay, so C vector X, if Y is Y, okay, X is 11Y and Z is 16Y. So this is telling you that there is more than one answer. Actually, there is infinite number of answers here. Okay, so it depends on Y. You can have associated X and Z coordinates, and again there is infinite number of answers. Let's give an example. Okay, so let's say if Y is 1, then X is 11 and Z is 16. If let's say Y is negative 2, X is negative 22 and Z is negative 32. Okay, you can come up with many different answers here. These are just 2 examples, but in general, that vector C, which is perpendicular to A and B, okay, in general can be written like this. Okay, let's look at example 5. A triangle is defined by 3 points A, B, C. Find the angle A of this triangle. Okay, so let's draw this triangle A, B, and C. Coordinates 0, 1, 2, 1, 0, 2, negative 1, 2, and 0. And we are looking for angle A. So if you didn't know the dot product uh, with algebraic vectors, that's how you would solve this question, right? So you would find AB vector, you would find AC vector, and you would find BC vector. Then, using those vectors, you could find the side lengths of this triangle. Then you could use cos law because if you know the three sides of a triangle, you can use cos law to solve for one of the angles. But actually now we are not going to use that method. That would take even longer time. But we're going to use dot product to solve this question. Because on the previous page we said that to find an angle, right, cos theta, we can do A dot B over, sorry, A dot B over magnitude of A, magnitude of B. Okay, we're going to use this information. Then we can find AB vector and we can find AC vector. Okay, so AB vector and AC vector, and then use this information or this formula to find out what angle A is. When you're doing this question though, make sure you take the vectors when they are tail to tail. Okay, so again I'm taking AB vector and AC vector. So do not take AB vector and CA vector because you're not going to get the same results. Make sure when you're taking those vectors that you want to do dot product, make sure that they are tail to tail. Okay, that's important. Then how can we find cos A? We can do AB vector dot AC vector and divided by the magnitudes of those two vectors. So where AB vector, so we know how to do it. OB minus OA. Okay, so 1, 0, 2 minus 0, 1, 2, 1, negative 1, 0. Okay, let's calculate AC vector. So that is OC minus OA, negative 1, 2, 0 minus 0, 1, 2. So negative 1, 1, and negative 2. Okay, we also need the magnitudes of AB and AC vectors. So magnitude of AB. So square root of 1 square plus 1 square gives you 2. Okay, so magnitude of AC, square root of 1 square plus 1 square plus 2 square gives you 6, so square root of 6. All right. Now let's do AB dot, let me write it so you can see it more clearly. 1, negative 1, 0 dot, negative 1, 1, negative 2. And we're going to divide this by root 2 and root 6. Okay. So let's do the dot product. 1 times negative 1, negative 1. Negative 1 times 1, negative 1. 0 times negative 2 is 0. And this is giving you root 12. So negative 2 over root 12 is 2 root 3. 2 root 3. Okay, so that's cos A. If you simplify this, I'll fit it here. Negative 1 over root 3. Now do the inverse to get the angle A. Negative 1 over root 3. So cos inverse negative 1 over root 3. So we get 125.3. 125.3 degree. So using that product for finding angles between the vectors is the easiest way. Okay. So let's look at example 7. For what values of k are vectors a and b are perpendicular, and for what values of k they are parallel or collinear. Okay. So if a and b perpendicular, again we know that their dot product is going to be 0. Okay, let's do the dot product. K times 2, 2k plus negative 2 times, okay, so negative 2 times 2k minus 6 plus 3 times 6, 18. That's going to be equal to 0. Okay, so we have 2k minus 4k plus 12 plus 18 equals 0. So negative 2k plus 30 equals 0. So 2k equals 30. So we get k equals 15. Okay, if k is 15, then a and b are perpendicular. Then what do we get here? A vector is 15, negative 2 and 3, and b is 2. 2 times 15 is 30. 30 minus 6 is 24. So 24 and 6. If they are parallel, we looked at it before. If A and B are parallel or collinear, then I should be able to get one of the vectors by multiplying the other one by a scalar. Okay, so then either I should be able to get, you know, a vector multiplying b by a constant, so let's say that is m. Okay, or I should be able to get b vector by multiplying a by a constant. So that constant can be anything, right? So let's say k times a. It doesn't matter which one you start with, you will get the same answer. Okay, so then vector a is k, negative 2 and 3, m times b is 2, 2k minus 6 and 6. So we get 2m, well, 2m k minus 6m and 6m here, and left side is k, negative 2 and 3. So if these two vectors are the same, then x coordinates must be same, y coordinates must be same, and z coordinates must be same. Okay, well, looks like this is the simplest one that we can solve for m if you look at the third equation. So m is going to be what? So divide both sides by 6, you get m equals 1 over 2. Okay, then we can use this and then put it in the first equation. Then k is 2 times 1 over 2. You get 1 for k. Okay, so and let's check if these two satisfies this equation. Because if it does, then we can say that m value is 1 over 2. But if it doesn't satisfy this equation, then we can say that there is no such a constant m to multiply b with to get a. Means that there is no way that a and b can be parallel. Okay, but if it satisfies this equation, that means that, oh, then m is 1 over 2. So let's see what's going on here. So left side, as you see, is negative 2. So let's look at the right side. 2 times m is 1 over 2. K is 1 minus 6 times m is 1 over 2. So this gives you 1, and that gives you 3. 3 and a half at negative 2. As you see, left side equals right sides. Yes, that m value satisfies also this equation. Okay, so it means that we can get a by multiplying b vector by half. Okay, 1 over 2 times b. And k is 1 in that case. Okay, so a is, let's put 1 for k, 1, negative 2 and 3, and vector b is 2. 2 minus 6 is negative 4 and 6.